On the bench, we have a 1968, I believe. Could be a late 67, but it's probably a 68. This is a Super Reverb. This is the AB763 circuit, which is the exact same circuit as the blackface version of this amp. As you can see, it's got the blue molded coupling caps in there, which are generally good. They seem to last forever, so you want to keep those if you have them. And somebody changed out some of the cathode bypass capacitors. So we'll take a look at the back panel, and I get my camera too close, so it gets a little fuzzy, but you can see that this one was made in the Santa Ana facility. So I'll take a look under the doghouse, and you can see somebody's been in there. I don't know what they were trying to accomplish, but in that spot there's generally a 20 microfarad capacitor, and they put in a 20 paralleled with a 30. But I don't get it. But the rest of them are 50 years old, and we're going to replace them all. So the amp came in, it was just the chassis. So the complaint was that the rectifier tube was bad, and it wouldn't power up, and it had some bad preamp tubes, which they supplied some new replacements for those. One of the first things I check is the fuse, and sure enough it was blown, so that dictates how I'm going to proceed. So I pull all the tubes, and I put plug it into my current limiter, and I check to make sure that the power transformer is okay. And I found out immediately that the power switch was bad also. So I'm not sure how they blew a fuse with a bad power switch, but I don't know, somehow that happened. So I'm going to put a jumper on that bad switch, and then I'll switch it back on, and we can continue testing our transformer. So I'll see if we do have filament voltage. And we do. It's not quite high enough, but that's because it's on the current limiter. And then I will test the high voltage going into the rectifier tube. Test each leg to ground there. We've got 357 volts, about right. The other side's 357. So it appears that the transformer is working just fine. So then I powered it up, and I wish I would have had this camera angle, but I didn't. I still had that overhead shot. And as it warmed up, the rectifier tube started warming up. My light bulb on the current limiter started glowing, and it started glowing brighter and brighter and brighter, and so I had to shut it off because obviously there was something wrong. I went into the doghouse and disconnected the B plus from the first two reservoir caps, and I tested it again, and the same thing happened, only it didn't glow quite as much because I was only testing the other four filter caps, but there was still something wrong, and I figured at that point it was leaky filter caps. So just to make sure, I turned the standby switch off, which disconnects the B plus from all the filter caps, or the other four, and tested again, and it seemed fine. There was no glow or anything, and then my hand accidentally bumped the rectifier tube, and my light bulb on the current limiter started flickering. So I had more than one problem. I tested the rectifier tube again on the tube tester, and it tested out just fine. So the next thing I want to do is check out that socket. And as it turned out, it just needed to be tightened up. I got the approval from the customer, and so I ordered parts, and in the meantime I'm going to clean up that doghouse. And so the first thing I'm going to do is clip these series capacitors out of here. You got to clip them out because the wires, the leads from these capacitors go in between the two boards, and so you can't really desolder those capacitors. You got to clip them, and then when you put the new ones back in, you got to just use the old hook and loop method, which works fine. But there's really not much you can do unless you want to pull these this board completely out of there, which means you got to disconnect all the wires and then take them apart, and nobody really does that. The hook and loop method works fine. It just doesn't look as clean. So these are strapping resistors, and what they do is when you have capacitors in series, they help regulate the voltage, make sure the voltage stays even, and they also drain the capacitors when the power's off, so you don't end up with the retained charge on those capacitors, which can knock you on your butt if you're not careful. So I finished clipping those caps out, and then I replaced those two strapping resistors. So then I finished cleaning off the board, and I replaced all the resistors. And now I just have to wait for the parts to come in. So I was digging around, and I found a power cord. So I thought I'd use it. It's 16 gauge, so I hook up the neutral right to the wide blade side of the convenience outlet, and that goes also straight to the transformer. Then the hot side connects to the other side of the convenience outlet. And because I want to try to use as much of the existing wire as possible, because it's an old amp, I use the ground switch as a terminal, so I can feed it all the way over to the power switch, which is bad. I'm waiting for a new one on that. And so the other side of the power switch then goes to the back of the fuse holder, and then the front of the fuse holder then goes to the transformer. I like to do it that way because I don't like that fuse holder being hot when the power switch is off. So you can see I disconnected the death cap also. So that ground switch doesn't do anything anymore, and the death cap is not connected. I also had a resistor to replace the one in the 50 volt bias circuit. I also ended up replacing that capacitor in there too. I already had some of the parts I was going to need, so I changed out the cathode resistors and bypass caps. The caps were electrolytics, so they had to be replaced, and the resistors were way out of spec. So the rest of the parts came in, so I replaced the power switch and all the filter caps and resistors. Now these caps are smaller than the original caps, and that rubber cushion that's in the doghouse cover does not really hold them down, so I use silicone so these caps are not hanging by the solder joints. So I go back into the chassis, and I want to change out the screen resistors and the grid stoppers, because they sit right next to the tube socket. They're right on it, and they get hotter than hell, and even though sometimes they look okay, sometimes you just touch them and they break in half. These were well out of spec too, and so that's why I wanted to change them out. So I clipped them out of there. So when I put the new ones in there, I leave some air gap around them so they stay a little cooler. These resistors are a little more robust than those carbon comps too. So when I went down the line checking for other resistors that are out of spec, I was mainly concerned about the plate resistors for the preamp tubes, because some of those were quite a ways out, and I've already replaced the cathode resistors, and the difference between the cathode resistor and the plate resistor is what establishes the amplification on those tubes. So you want to get accurate resistors in there, so you don't want a bunch of them that are out of spec. So I hooked up the shop speaker and turned on the amp, and it was humming pretty bad. So I shut it off, put my bias probes on, and checked the bias, and one of the output tubes was running at about 22 milliamps on the plate, and the other one was running at about 5. So with that big a difference, that's probably what's going to cause the hum. So I let the customer know, and told him we needed to get a pair of 606 GCs, some new ones, and put those in there and bias it, and he'll be all set. So I finished all the repairs. You can kind of see some of them from here, but I'll show them a little bit closer. Of course, whenever I do any of these, I go and clean all the pots, all of the tube sockets and jacks, and it's a standard bench procedure that when something goes out, all that gets done before it goes. These are the tubes that I ordered that came in, and I got those in and got them biased. And so I'm kind of show some of the components that were replaced. There was quite a few that really did need to be replaced. Resistors that were way out of spec, and get those particular resistors on the output tubes. There's a new cap on the bias voltage, and you can kind of see where the new components are as we go down the line. And these are all the small components that I put in this bag. I'll send those back with the repair. And this is a box with the larger components in it. You can see the old tubes, the cord, all the caps. Replaced the power switch and rewired all that to bypass the ground switch and the death cap. So I'm getting set up to do a test on all the features, reverb and all that. And here's the speaker and guitar. Everything's plugged in. You can see the jumper I have for the tremolo, and my reverb can is back there. So you won't be able to hear anything because I don't have any good microphones for doing that. That's why I have to voice over the videos, because I don't have good live mics. So you'll just have to take my word for it that everything's working. And that is a wrap on this one. Thanks for watching.